This is the first video of BFDI Science, a video series where I will do science in BFDI. But first, I need to explain some things. In real life science, a hypothesis is tested by doing experiments. But BFDI is a video series, so we can't do any experiments and we can only work with information in the show. I will also assume that the laws of physics are the same as real life, unless they can't explain something seen in the show. And trust me, there are a lot of things that happen in the show that can't be explained by the laws of physics in real life. With that out of the way, we can start measuring characters. This will be useful to measure other things later. In BFDI 7, when Lewis is introduced, there is a box on the top left of the screen that says that his height is 10 feet, which is 3.048 meters. We can then use Lewis to measure Fries and FSB and those to measure other things. You might be tempted to measure the height of the characters, but here the most important thing is that the length we measure can be measured easily and precisely, without having to guess what is the top and bottom of the character. Instead, I will usually measure a straight line or the distance between 2 points on a character. For example, I will measure the length of the left side of Fries and not the height. An exception to this are circular characters, like golf ball or donut. Instead, I will find their radius. You might think that finding the radius of a circle would be hard and imprecise, since for that you need to find two opposite points, but there is a more precise way to find it. The first step is to pick 3 points on the circumference. Which 3 points you choose aren't important, but it is better to choose points that are approximately equally spaced in the circumference. There is only one circle that passes through any 3 points, so we just need to find that circle. But how do we do that? First, we need the circumcenter of the triangle formed by the 3 points you choose, which is the center of the circle. If the 3 points have coordinates x1, y1, x2, y2, and x3, y3, the circumcenter's coordinates uppercase x and uppercase y are given by these equations. The radius of the circle is the distance d from the circumcenter to one of the 3 points xy, which is given by this formula. Or you can put the 3 points in GeoGebra and use the circumference from 3 points too, and you can find the radius of the circle by taking the square root of the value after the equal sign in the circle equation, or by dividing the perimeter of the circle by 2 pi. First, let's measure Fries and FSB. This sardine Fries has a length of 939.9 pixels, and FSB has a height of 742.0 pixels. Well, how do we convert from pixels to meters? The length in pixels is directly proportional to the length in meters. So if we know one of the lengths in the image in pixels and meters, we can find the length in meters of any length that we know the size in pixels. So we can write this formula where uppercase L1 and uppercase L2 are the lengths in meters, and lowercase L1 and lowercase L2 are the lengths in pixels. If we know uppercase L1, we can solve for uppercase L2 by rewriting the equation as this. If you are making multiple measurements in a single frame, it is faster to compute the scale as equals uppercase L1 divided by lowercase l1 once, and then multiply the result by the length in pixels of what you are measuring, so we can write the following expressions. Note that different frames may have different scales. Using the first formula, we can find that the scale of this frame is 0.003 meters per pixel. Using the second one, we can find that this side of rice is 2.81 meters long and FSB has a height of 2.22 meters. Now let's measure tennis ball. To measure him, we need a frame that includes him and a character with known length. So I will use this frame that has tennis ball and fries. Tennis ball is a ball, so we need to find his radius. By putting the frame on GeoGebra, we find that TB has a radius of 477.7 pixels, while the side in France has 752.3 pixels. By using the length formula, we find that TB has a radius of 1.78 meters. Before I end the video, I would like to say that I may make some mistakes in the videos. If you catch one, please say it in the comments so I can correct it. I'm planning to make a pinned comment with minor mistakes, and if there is a big one, I will remake the video, but I'm still not sure what to do. I would also encourage other people to also contribute to this and to make their own theories on how the BFDI world works. It would be good to have a big community. Maybe one day we could explain how everything that happens in the show is possible, but if this happens, it will take a long time. This is all I have for the video. Stay tuned for next time, where I will talk about atoms. Goodbye.